Assalamualaikum and good morning. I'm Puan Rosmawati binti Kadir from SMK Tunku Abdul Rahman, Nebung Tebal, Pulau Pinang. Today, our topic will be differentiation with the subtopic implicit differentiation. Our objective today, I expect you to be able to define implicit functions and differentiate implicit functions up to second order. What is implicit functions? A function where y cannot easily be made as a subject. Or in a simple word, I can say that implicit functions is a function when you come across y is not easy to be written as a subject. Okay, there are two examples here. The first one, 2x squared plus y squared minus y equal to 4. Okay, here we can see that y is not easy to be written as a subject. Okay, and then the second example, ln x plus y squared plus 2 square root y equal to 1. In this second example, y also is not easy to be written as a subject, or we can say that y is not given implicitly as a function of x. Differentiation of implicit functions. To find dy dx, we need to differentiate each term with respect to x. Or in general, if we do have gy, if we want to differentiate the gy, we need to differentiate the gy with respect to y first. Then we're going to multiply it with dy dx. Here it's some sort of, we are using chain rule. Let's see example how to conduct implicit differentiation. I put example 1 here. We want to differentiate the equation with respect to x. The first example, A. We want to differentiate y. So when we want to differentiate y, we must differentiate the y with respect to y first, which is equal to 1. Then we need to multiply it with dy dx. Hence, the answer will be dy dx. Example B. We want to differentiate 3y squared. We need to differentiate the 3y squared with respect to y first. It will be equal to 6y. Then we multiply it with dy dx. Hence, we will have the answer differentiation of 3y squared is equal to 6y dy dx. Example C. If you want to differentiate e to the power of y, differentiation of e to the power of y, by using the same concept, we will have the answer e to the power of y dy dx. The same goes in example D when we want to differentiate the ln y. Differentiation of ln y will be 1 over y. Then we multiply it with dy dx. So our answer will be 1 over y dy dx. We move on to next example, example E, where we come across differentiation of x squared multiplied with y cubed. In this case, we have an expression of product of, where we have x squared multiplied with y cubed. So in this case, we need to use product rule. Recall the formula of product rules. When we want to differentiate uv prime, then we should have uv prime plus vu prime. In this case, we're going to treat the x squared as u, meanwhile the y cubed as v. So we copy down the x squared, then we multiply with the differentiation of y cubed, plus with, we copy down the v, which is y cubed, and multiply with the differentiation of x squared. So here, when we differentiate the y cubed, we will have it 3y squared dy dx. So the first term here, we're going to have x squared multiplied with 3y squared dy dx. And the differentiation for the second term here, okay, we need to differentiate the x squared. The differentiation of x squared will be 2x. So we multiply with the y cube. Then the final answer will be 3x squared y squared dy dx plus with 2xy cube. Okay, next example. Okay, here we do have differentiation of y over x. Okay, in this case, we have quotient function. So we need to treat it by using quotient rule. Okay, still remember what is quotient rule? Okay, so recall your quotient rule formula. When you have u over v, you want to differentiate it, then it will be vu prime minus uv prime over v squared. Okay, in this example, we need to treat the x or the numerator as u and the y, which is denominator, is treated as v. So we fill in this x and y into the formula, then we will have y differentiation of x minus x differentiation of y over, okay, everything over y squared. So when we differentiate the x, okay, we will have y. So the first term here, we will have y multiplied with 1. Then minus, so for the second term here, we will have differentiation of y. Differentiation of y with respect to x will be dy dx. Hence, we will have, for the second term is x dy dx. So this, everything should be divided by y squared. Okay, so finally, we're able to write the answer is y minus x dy dx over y squared. Let's move on to an equation. In example 2, we want to find dy dx in terms of x and y if we are given x squared plus y squared equal to 4. Okay, we do have an equation, so we need to differentiate both sides with respect to x. Okay, let's differentiate the left side first, where we do have x squared plus y squared. So the differentiation of x squared, okay, going to be plus with the differentiation of y squared and then equal to the differentiation of the right side. Okay, when we do differentiate the x squared, we will have it equal to 2x. Meanwhile, when we differentiate the y squared, okay, we will have it 2y. Okay, don't forget to multiply with dy dx. And on the right side, when we differentiate the 4, we will have equal to 0. Okay, do remember the differentiation of a constant will be 0. Okay, and then we will have 2y dy dx equal to negative 2x. Okay, dy dx will be located on the left side, then the rest will be on the right side. So we will have negative 2x over 2y. Okay, after this, we need to simplify the differentiation by cancel off the 2. So we will have dy dx equal to x over y. Okay, in next example, example 3, we want to find dy dx of e to the power of y multiplied with x squared plus 2y equal to 3x cubed. So this is another example of implicit equation or implicit functions. Okay, so in order to differentiate this equation, we need to use product rules because we come across e to the power of y multiplied with x squared. So for this term, okay, for this particular term, we're going to use the product rules where the ey is treated as u and the x squared is treated as v. Okay, let's focus for this part. So the differentiation of this term will be ey, we copy down the u, which is EY, then we need to multiply with the differentiation of x squared, which is equal to 2x. So we will have EY 2x. And then plus, okay, V multiply with U prime. So the V here we copy down, which is x squared, and then multiply with the differentiation of EY. Differentiation of EY will be EY dy dx. So we done for this part. Plus with the second term, which is 2y. Okay, we want to differentiate the 2y. Differentiation of 2y will be 2 dy dx. And then on the right side, we need to differentiate 3x cubed. Okay, differentiation of 3x cubed, we will have it equal to 9x squared. So here we can see that there are two places of dy dx. So when you come across this kind of equation, okay, when you have two places of dy dx, you must gather it. Okay, how to gather it here? How to gather the dy dx here? Okay, so you factorize it. Okay, when we gather it on the left side, we will have x squared multiplied with e to the power of y plus 2. Okay, and then we multiply with dy dx. And on the right side, also we can factorize because we have common factor there, which is x. So we will have x, 9x minus 2 e to the power of y. Okay, now we already have dy dx as a single item. So everything else we move to the right side. So in this case, x squared ey plus 2 is shifted to the right side as division. So we will have the answer as x multiplied with 9x minus 2 e to the power of y, everything over x squared e to the power of y plus 2. We move on to second derivative of implicit functions. Okay, remember our objective today. We have two objectives. The second objective, you need to be able to differentiate implicit functions up to second order. So in example 4 here, we're going to do that. Okay, if we are given x squared plus y squared equal to 2y, show that 1 minus y cubed d2y over dx squared equal to 1. So here, okay, you can see that d2y over dx squared, that one is second order of differentiation. So in this example, okay, we also need to do implicit differentiation because y is not easy to be written as a subject. Okay, so we differentiate term by term. The first term here, x squared. So we need to differentiate the x squared, which is equal to 2x. And then plus with the differentiation of y squared. Okay, still remember what is differentiation of y squared? Okay, differentiation of y squared will be 2y dy dx. Okay, so we're done for the left side. And then we continue with the right side. Differentiation of 2y on the right side will be equal to 2 dy dx. Okay, in this line, we can see that we have two places of dy dx, one on the left and one on the right. So we gather these two at one side. Okay, we gather these two at one side. Then we bring the dy dx on the right, bring it to the left. Okay, and before that, we can simplify the coefficient 2 for each term. So we will have x plus y dy dx equal to dy dx. Okay, when we gather it to the left side, we can factorize it. Then it becomes y minus 1 dy dx equal to negative x. Okay, this equation we also can rewrite so that our x is positive, hence it becomes 1 minus y dy dx equal to positive x. Okay? Okay, so after this level, we can do differentiation in order to have second order differentiation. Okay, we able to do it either differentiate implicitly once more, or we able to use quotient rule by rephrasing the dy dx equal to x over 1 minus y. Okay, since we are learning implicit differentiation, so I conduct the next step by using implicit differentiation. So I'm using the line of 1 minus y dy dx equal to x. So now we want to differentiate once more time so that we will have the second order, which is d2y dx squared. Okay, since here it is a product of 1 minus y multiply with dy dx. So these two is a product of. So we must use product rule, okay, where 1 minus y is treated as u, dy dx is treated as v. So we copy down the u, okay, so we will have 1 minus y. And then we need to differentiate the v. Differentiation of dy dx will be d2y dx squared. So this is what we call second order. And then plus, okay, we copy down the v, which is dy dx. And then we need to differentiate the u, which is 1 minus y. So the differentiation of 1 minus y will be negative 1. Okay, and then we need to multiply with dy dx because we are differentiating the negative y. And then on the right side, we have x. So the differentiation of x will be 1. So in this line, we can see that we have dy dx multiply with negative 1 multiply with dy dx. So for this part, it becomes negative dy dx squared. So the next line, we will have 1 minus y multiply with d2y dx squared minus dy dx squared equal to 1. Okay. And then I replacing the dy dx by x over 1 minus y. Okay, because earlier we already have dy dx, which is x over 1 minus y. So I am replacing that at the place of dy dx. It means we will have 1 minus y d2y dx squared minus x over 1 minus y squared equal to 1. So here, we almost get what being required in the question. Okay, let's recall the question. We want to show 1 minus y cubed. Okay, but here we don't have cube yet. We only have 1 minus y. And then in the second term, we have over 1 minus y squared. So this line, where I circle it there, I multiply everything by 1 minus y squared. Hence, we will have 1 minus y cubed d2y dx squared minus x squared equal to 1 minus y squared. Okay, after we multiply, I bring the x squared to the right and I expand the bracket squared. Okay, so I will have 1 minus y cubed d2y dx squared equal to 1 minus 2y plus y squared. Okay, this part, the first three terms on the right side is coming from the expansion of the bracket squared, 1 minus y squared. Okay, so when we expand it, we have 1 minus 2y plus y squared. And then we do have x squared. the one that we shifted from the left to the right. So here we can see that we do have y squared plus x squared. This 2 is equivalent to 2y. So we can substitute 2y for this part, so that we will have on the right side 1 minus 2y plus 2y. So we can cancel off the negative 2y plus 2y, which is become 0. Hence, we will have the answer, okay, we able to show that 1 minus y cubed d2y dx squared equal to 1. In next example, okay, we have if y equal to x multiplied with e to the power of 3x, we need to show that d2y dx squared minus 6 dy dx plus 9y equal to 0. In example 5, we are given if y equal to x multiply with e to the power of 3x, we need to show that d2y dx squared minus 6 dy dx plus 9y equal to 0. In this question, we need to show that there is no x in that question. To answer the question, we need to differentiate it. As usual, we need to use a product rules for the right side. So on the left side, we do have y equal to x multiply with e to the power of 3x on the right side. Differentiate the left side, differentiate the y will be dy dx. Differentiate the right side, we will have x multiply with the differentiation of the v. Remember the product rules? So x multiply with the differentiation of e to the power of 3x, which is 3 multiply with e to the power of 3x. And then plus with vu prime. So v here, we just copy down e to the power of 3x and then multiply with 1. So we no need to write down the 1. So we will have the line will be dy dx equal to 3x multiply with e to the power of 3x plus e to the power of 3x. Okay, here I already highlight the x multiply with e to the power of 3x. Why I highlight this part? Okay, because if you do realize, this part is exactly equal to y. So I able to write for the x e to the power of 3x, I able to write it as y. So I will have dy dx equal to 3y plus e to the power of 3x. Okay, then I need to differentiate once more so that I will have the second order, which is d2y dx squared. Okay, so our d2y dx squared will be equal to 3. Differentiate the y, we will have dy dx plus the differentiation of e to the power of 3x, it will be 3 e to the power of 3x. Okay, 3 to the power of 3x, okay, where I highlight the e to the power of 3x, that part can be rephrased as dy dx minus 3y, because earlier we already have dy dx is equal to 3y plus e to the power of 3x. So e to the power of 3x, I put in as dy dx minus 3y. So now, everything in the line, no more x. Okay, no more x in that line. Okay, so we try to manipulate this equation so that we will have similar as required in the question. Okay, so the next line, we will have d2y dx squared equal to 3 dy dx plus 3 dy dx minus 9y. So we have two places of dy dx, or I do have 3 dy dx plus 3 dy dx. So this become 6 dy dx. Okay, therefore I will have d2y dx squared equal to 6 dy dx minus 9y. Okay, shift everything to the left so that we will have exactly d2y dx squared minus 6 dy dx plus 9y equal to 0. That's all our examples. So, for you to enhance, okay, for you to understand better, I give you 2 exercises. Here, 2 questions. The first one, I ask you to find the dy dx of 3x squared minus 2y squared equal to 6x minus 4y. Okay. B, you need to find dy dx for y squared equal to ln x squared plus y squared. And then second question, I want you to show that, okay, second question is a second order differentiation. If you are given y squared equal to 2xy plus 2x squared, show that y minus x multiply with d2y dx squared minus 2 dy dx plus dy dx squared minus 2 equal to 0. Okay, here I already showed the answer. Okay, you may check the answer. Okay, and then you also may discuss the question with your teacher. So today, you have learned how to do implicit differentiation. I hope all of you able to understand and you able to enhance your understanding by doing some questions as shown on the screen. You may discuss with your teacher for further explanation. Okay, the answer also given, so you may discuss with your teacher. Thank you very much.